su-oracle, and I must start minikube also. Minikube status, because I restarted my system, it might not be running. Yeah, it is stopped. So start. So this will start because it will not take much time this time. So now I'll proceed with this what I'm doing. Make directory my eager front end, my eager and back end, and go to this my eager directory. Now therefore if I try tree command here, that will show me two directory backend and front end. We are going to create image sample application in these directories, and we are going to create an image out of those source code, and we'll build that with and without tracking Python file. So this is in front end directory frontend.py, that is Python. So here you see we are importing two libraries. One is operating system for operating system commands. One is for requests, that is implement our library, and from Flask import Flask. So we are importing them, and we are putting some Flask is a normal counter actually. It is just a simple application which is counting the visitor. So it will display the message you are visitor number, and it will display the visitor number. That's it. Not going to do much of the work because our objective is not the functionality. So we create a Docker file. Docker file is a step-by-step instructions to build the image, Docker image from the source code. And that's what precisely we are going to do. I missed the hash. So this is my Docker file I'm creating. Let me explain what this Docker file is doing. From Alpine. Alpine is a base Linux utility which offer a lot of Unix commands. And then run apk add no cache, add these packages. These packages will be added, and then install Flask requests, whatever is given in our source code, and then copy all the files from this directory, which is actually nothing but right now frontend.py. Copy that py file into user source frontend, and then environment variable frontend.py, and then work directory, go to this directory and run the program and open the port number 8000. So this will create a Docker image from this source Docker file using the source code we created. So it will be ultimately a program which will display the counter number, which will count. So I need to log into my Docker hub. So sudo docker login docker.io. It will ask me my Docker user ID. If you don't have an account, you have to create it. If you don't have any account on Docker hub, you need to create it, and you need to provide that account credential to log in. So login succeeded. I'm logged into my Docker hub. So which means I can build an image from this Docker file using the source code. I can push that image to Docker hub, which I'm going to do now. So this command will build the Docker image with tag name, which is in the format account name followed by my image name followed by tag name followed by this no, from the directory where the directory is. So let me give it v1.1 as an example. The tag name can be anything. So this is a version 1.1, and front end this image will be created. So it will pull the source code, and it will show all the 6 steps mentioned in that command. So it is pulling the source code and then checking it and installing all the packages which were listed here, and now it is executing it, and it will, once the image is successfully built, it will display successfully built. These are warnings. That's fine. Now I can push it to my Docker hub. So image name was 1.1. Now I will not forget it. So this is pushing the image to my Docker hub. Now I can specify this complete path in my Kubernetes manifest file to deploy this image in Kubernetes, and my Kubernetes is running, so I'm ready to deploy the application even. So in the meanwhile, I can open another tab and use this effective time when it is building, when it is pushing, I can create the backend. So backend.py, that was the front end. The explanation of the code is written in the documentation also, but briefly we are importing random. From random we are importing random integer. From timer we are importing sleep. From Flask we are importing request. So this is Python classes, Python packages, and we are importing specific functions from those, some specific object classes from those libraries. from the apps, sorry, packages. And then they are all defining this variable and working with it. So these are functions. The def actually is function. So get counter, increase counter, and define the counter. So that means the counting which was being done by front end is actually implemented in this program backend.py. So Docker file, insert. So code is more or less same from Alpine 3.8. So install packages, copy the file, backend, and then open port number 5000. So backend will be running on port number 5000. So build hyphen t tag name, my account number, and this is counter backend. So version 1.1 of my backend from the backend directory. So this will build the backend image also. I got both the image. This image is already pushed now. You can see that. And backend also I'm going to push. The way I push this, I'm going to push that also. So once my image is successful, so version 1.1, that is backend. Both my images will be available on Docker Hub. Oh, come on. Let me try from here. Docker push sang 170 visitor counter backend 1.1. What is the image name? What we build? Oh, V1 only? Is it? Oh, 1.1. Yeah. That was a typo. Correct. So I need to this specify this only. Correct. So this will push my backend image. I forgot to type dot. I intend to type dot, but that's okay. As the image is being pushed, we are using frontend deploy frontend.yml for Kubernetes, the my image details. So I know what my image is. My image is TSP visitor counter backend default.svc. No, this is not one. The frontend was version 1.1. So I need to type that version 1.1. So this will pull that image from GitHub and it will deploy it. Environment variable is counter endpoint and the value is given by this, which is coming from the backend. This is calling the backend program. So this will deploy. The name is this is front end. The name is TSP widget counter front end, and this is TSP widget counter backend. From that default SVC cluster localhost local 5000. So it is going to pull the counter value from the backend program, and it will be serving that into port number 8000. So this is a without any tracking, without any implementation on any class libraries for this monitoring and tracking. So this is a simple application. So this is backend. This is the backend program. So here the my image version, I will remember that it was not backend version 1, it was 1.1 as you said. And this is the service which is creating TSP visitor counter backend, and the selector is visitor counter backend, and this will be serving on port number 5000, which will be accessed by the front end. So we have two containers created. So deploy front end. Localhost 8080 was refused. Oh, that 8080 might be used by some other application. So I need to remove that. I hope my cluster is running. Yes, you remember that the eager service is not running and that eager must be running. Let me check that. Docker ps and docker start. The same thing which was happening earlier also. This one. That with the eager service. Oh God, I am executing all these commands at root user and my minikube is working as Oracle user. This is a major thing, major problem. So I need to move all these files to my Oracle user. So cd dot ls, yes, mv my eager to slash home slash Oracle and chown. And this was the minor issue because I by default logged in as root user, which I should not have. Chown Oracle dot Oracle slash home slash Oracle and my eager. Now I should switch back to Oracle user. su hyphen Oracle and here I can see cd my eager, and I have those images also. And let me use docker login again. Docker login. No, no, permission I change. Wow, come. Oh God. I forgot to use hyphen R. Let me do it again. Hyphen R. Now it is okay. Yes, now it is okay. Now Docker login, Docker sudo is required. Without sudo it will not work. Sudo Docker login, docker.io. Oh, it is already authenticating user. So good. Because my mini, why it is not saying? Oh, see, come on. Silly mistakes are happening, my eager. And now this will work. Yes. Now front end is deployed. Now we can deploy the backend also. The front end is created successfully. Both will be deployed in our Kubernetes. Yes, backend is created and service is also created. Now our app is up and running. Our app backend and front end both are working. So I should open the firewall port 8000. As you know, it is available on port number 8000. So firewall hyphen cmd hyphen list hyphen all. I want to check whether 8000 is already open or not. 8000, yeah, it is open, so I can visit port number 8000. This is my app. You will get my app here. Oh, come on. That will show me. If it is creating, then it will take time. Yeah. Need to forward the port from the container cluster from this pod to my host name. And this is how we do port forwarding. kubectl port forward, get pods, app name is TSP visitor counter front end, and forward this port number 8000 to 8000. And after that, I'll be able to access it. Yes. Now I can access it, but not here inside my machine. You are missing. When you are forwarding the port number, it will be forwarding to the local host. So let me check inside the machine colon 8000. Yeah, it is coming. Hello world, we are visitor number 1 here. So let's open another terminal window, and in that window we run this command counter for I equal to 1 2 3, and we are calling this local host on 8000. So this time it will execute this command visitor number 1, visitor number 2, visitor number 3. The counter will start as I pushed it into a loop. In fact, that will visit here, that will display here, because we are using curl command. So it is displayed here only. So it is counting. The program running on port number 8000 is called thrice, and every time I'm getting the visitor counter increasing because of my backend program. So this is a simple program. It will work here. So create this eager tracing. It is already existing, that's fine. If not, that's okay. Let's create a service account for this. Create service account, eager operator master config, role based access control, service account.yml. Service account is, so this will create a role. If the role is already exists, perfect. Because if role manager is already there, then role binding is already okay. Role binding is invalid. That's fine. This is also deployed if I'm not wrong. Okay, eager operator created. Then I can expect that already available. And if it was not, it will create it. So it is created. Any of them is crashing, I will be okay. So it is still creating container. But this time, remember that pods we have deployed in Kubernetes, we created backend and frontend two programs. Backend is creating, increasing the counter. Frontend is displaying that counter, and there is no tracing as of now for these. So one backend is running successfully. Simple test is not running. Simplest is not running. So let's see. After some time, it may also come back. It takes some time. Sometime it takes some time, and crash loop work after 2 3 attempts it will work. It should work. 16686. It is forwarding on port number 16686. So let's visit this 16686. Localhost colon or 666. I done the typo. So this is our eager. Right now there is no service, and this is our intention. We are running no service. Our ride hot demand ride on demand hot ride on demand application is not running. We are this time creating a program from scratch, and right now there is no service. It's worth observing there's only one service, jQuery, and even if you try to find something, there is nothing available. And services, the operations are available, but that driver or the, sorry, backend and front end, we are not able to see anything here because we are not tracing. We need to enable the tracing and we need to see those output for the front end and back end here. So our objective is to how do you implement instrumentation in front end and back end to enable tracing in another terminal window, because you cannot control this, or you want to stop, you can stop, though it is not recommended. Let me run another version, su oracle, and here cd my eager, and I add instrumentation to my frontend.py. After adding instrumentation, I'm going to launch my app, create image again, push it to GitHub, and then deploy it on Kubernetes, where Kubernetes operators are already launched. So therefore, I should be able to monitor this app. Functionality, as I said, is not our concern. Our concern is the monitoring, which I'm going to introduce here in this area. After this line, so let me add this tracing part. Now see the tracing tier team. From eager client, import config. From flask operator, this open tracing, import flask tracing, and this is app name configuration, and this is what we are going to do. This is what will be available for us for tracing. So logging is true, reporter batch size is 1, service name is service, and eager tracer config initializer tracer, we are calling this method, and tracing is enabled on this app. That's the code we were supposed to add for tracing. Let's add this tracing to the backend program, and similarly, because the file is already existing. No, in first attempt we created file without tracing. I'll not say this much, similar to this, only similar to this, not much of the code. You just need to enable that much, because your app might be different. This is a Flask app we are using. Your app might be different. This is a main class name, main package. This is a package of Python. So for SAP, only this much of code, only this much, using the given class and function. So what we are doing right now, so let's add this line given in the yellow color at the end of this line and save it. Similarly for backend also program. So same, go to the last line and add the because I have given the right instructions in proper coding and background color. Build, but this time it is version 2 for front end, and then I will be building version 2 for back. So after this library is implemented in this code, we will be able to see the traces in our eager. That's the main objective and idea, which was, I can stop this now because I don't need that. I needed to enable tracing now. So let me build that file. Yeah, this is done, and I'm pushing this also. Backend version 2 and front end. So both files, once they are pushed, so I'm ready for that also. So cd my eager, and we'll make that change into, I should be working into this home directory. Okay. So here I need to make one, enter the line, and remember to indent, please, because this is a common error. Annotation should be below the label. So because whenever you talk about this Python files or YML files, indentation plays very crucial role. Save and quit. We'll add annotation to this program as well. So one character can play spoil sort. So we created this also. So all is good now. Both Kubernetes. Oh, sorry. We need to change the image also. Of course, yes. Come on. That's a big thing you have noticed. Thank you so much. So this time it will be image version 2, and that will be there in the lab. That you will see in the PDF. I'll show you. Version 2 we are deploying now. Perfect. front end and back end. This will be version 2. Naturally, we are deploying version 2, no doubt. Interestingly, in kubectl, we deploy using the same command, same path, everything. You just use, instead of apply or create, you put delete, and we'll be able to see the traces in our. This is my front end created, and now I should be tracing this. Let me refresh. So it is container creating, and of course we need to do the same port forwarding also. Terminating old containers, creating new containers. Allow, give it some time. Now I can run it. So this will do my port forwarding to port number 8000, and now I can try. Because of the port forwarding, I'll not be able to access the first window and second window. Now it is counting. It will start counting. It will start showing the counter here. Yes, now you should be able to see the services and traces. Let me see. After some time, I should be able to see more driver and this also. Come on, it will show me operations all. So I should be able to see more traces. Let me see, give some time. And let me run the commands here, the counter once more. Find traces, all app traces. Yeah, I could see only one trace here. What is this query? Which process is being used? Simple test. That pod is crashing. So that is the reason I'm not able to see why this is crashing. I need to figure out this. The simple test pod was crashing, and that is the reason unfortunately I'm not able to see that example. The tracing I'm not able to see because of this. kubectl get pods. Yeah, crash loop back. Correct. Of course, I need to use sudo. Yes, and I'll run this also. This is the solution generally we receive because of this crash loop billet. This is actually, we do this for 3 node cluster. Kubernetes is not running here, that's fine, but I can switch to Oracle user and I can try out now. Let me see. Generally, IP table is the culprit. Yes, that is not starting. I need to start this again. Yeah, this is stopped. Minikube status. I don't think it is running. Yeah, we need to start it again. And this time I'm hopeful that I'll get my deployment running. So let's wait. This, yeah, let's see. Completed, running, still error, still there's error. Anyway, team, I'll try to figure out why this eager operator is throwing error, and if possible, I'll fix it and let you know. Eager monitoring eager metrics, Prometheus monitoring mixin for eager. That's a quick agenda, not more than 10 minutes topic, and logging and traces. Monitoring eager. Eager itself is a distributed microservices based system. If you run it in production, you will likely want to set up adequate monitoring for different components, for example, to ensure that the backend is not saturated by too much of tracing data. By default, eager microservices expose matrix in Prometheus format. It is controlled by these command line options. One is admin HTTP host port, the port number where the HTTP admin server is running. Second, matrix backend. It controls how the measurements are exposed. The default value is Prometheus. Another option is xvar, the Go standard mechanism for exposing process level statistics. Then matrix HTTP root. It specifies the name of HTTP endpoint used to scrap the matrix, that is /matrix by default. Each eager component exposes the matrix scrapping endpoint on the admin port, and the component is agent is exposing at 14271. Collector is exposing at 14269. Eager query is exposing at 16687. Eager ingester is exposing matrix at 14270, and all-in-one will be exposing at 14269. Prometheus monitoring mixin for eager. The Prometheus monitoring mixin for eager provides a starting point for people wanting to monitor eager using Prometheus, Alert Manager, and Grafana. And the details of this mixin plugins are available here. This include a pre-built dashboard also, logging. Eager components only log to standard out using structured logging library, which is go.uber.org/zap, configured to write log lines as JSON encoded string. For example, the log level can be adjusted via log level command line switch. Default level is info, and this is which is given here. Level is info. Eager has the ability to trace some of its own components, namely the request to the query service. For example, if you start all in one and refresh the UI screen a few times, you will see eager query populated in the service dropdown. If you prefer to see those traces in the eager UI, you can disable them by running this backend component with extra environment variable, that is environment variable eager disabled equal to true, and rest of the settings remain the same. That will disable the tracing. And that's all for this eager tracing, eager disabled equal to true environment variable. For example, this is the command. That's all for this session. Thank you very much.